section 4. So section 4 is mostly security and the security around your Azure process and what services Azure has for security for you. So as you kind of go through this, this section is 10 to 15% of the exam, and based on mine, I actually got a lot of questions on security, surprisingly. So it felt like more than 15%, but it's probably really only 15%. So the big things to remember is that security is integrated into every aspect of Azure. It's really part of the Microsoft culture. It really is something that you're going to be able to take advantage of while you're in the Azure environment. Take advantage of their ability to do things at scale and their ability to really find really good security people and use those security advantages to your best benefit when you do your company in Azure. The powerful combination of people, applications, data, compliance, everything really helps provide a very cost-effective ability for you and any organization, no matter the size, to really have some really good cost-effective security, and probably in ways that they wouldn't be able to have security at all if they were trying to do this on their own. So Azure's security design is basically that they know they're a public cloud service, and they know that they're going to support technologies that support millions of developers and IT professional and customers, and you have to trust them. So when you build on or migrate any of your IT assets to a cloud service provider, you're relying on that organization's abilities to protect your applications and data with the services and controls they provide. And that's the big one, right? You're going to be able to leverage their services, their controls, their compliance, and actually save you some money. You don't have to certify your data center now. You just have to certify your application because Azure's data center is already certified, depending on what kind of compliance you need to: HIPAA, HITRUST, SOC, Sarbanes-Oxley, GDPR, you name it, they've got a compliance statement for it. And again, Azure's infrastructure is designed to go from facility to applications. And again, millions of people, millions of businesses, millions of everything, a huge economy of scale to build a trustworthy foundation upon which your business can meet their security and compliance requirements. Right? And there's a lot of neat things that they'll provide you to help you get there, to help you meet all those things that you need to meet for your company. So everything is managed through your subscription. Depending on the cloud service model, there's a variable responsibility for who is responsible for managing the security of the application or service. And that's a real big one. Depending on which one you do, infrastructure, platform, software as a service, whichever, you have a matrix of things that you're responsible for and things that you are not responsible for. So make sure that you understand that whole process. You'll see that matrix a little bit later on in this. But again, you can do this pretty much so on your own as long as you understand what your responsibilities are. There's a lot of built-in capabilities. And they've gone ahead and they've organized these in 6 functional areas: operations, applications, storage, networking, compute, and identity. So you can build on any one of these. You can build on all of them, but you can leverage everything that Microsoft has put in place for those. There's also a security services map. This map helps you organize services by the resources they protect. So you can secure and protect those services like Sentinel. That will actually help you build your defense in-depth strategy across all of your stuff, your hosts, your data, your networks, and services and capabilities that help you understand and improve your security posture across the Azure environment. Things that detect threats, so you can identify suspicious activities, mitigations, including automated mitigations, especially when it comes to mitigations for denial of service. Some of those will kick in automatically. And investigate and respond. And that's the important part. Investigate services that can pull logging data so you can access activity and then respond appropriately to whatever that activity is. This is the security services map. You'll find this all over in all of their documentation. This is a good map to know and understand in terms of what their capabilities are for secure and protect, detect threats, and investigate and respond. So it's really kind of neat where it goes in the tools and the systems that are in there for you to be able to use along the way. So in summary, right, there's a lot of security services. You're going to learn a whole lot about them in this section. You're going to want to know them overall and what they do for the test. But there's a lot of really neat things baked into Azure based on 30 years of Microsoft being the largest target on the network or on the internet ever, going back to Windows 95 or before. So it just makes this all the more interesting. And I think you'll enjoy this section if you are interested in security. This is the most interesting section of the test. So I will see you in the next lecture. We've got an amazing section 4 to go through. 4.2, we're going to talk about Security Center. It's a little bit of policy, a little bit about alerting, security scoring, and resource hygiene. So the interesting part about the Security Center is it really is your one-stop shop for all of the things that you would need to know about what's happening with the security posture of your subscription. So you'll see it in some of the documentation referred to as Azure Defender for the cloud, as Azure Security Center. They both tend to kind of look the same. I know there are two different names for everything. I think that looks like they're in the process of changing a name over. But the big thing about the Security Center or Azure Defender for the cloud is that it is the place to stay up to date for everything that's going on in Azure and in your installation for Azure. So you end up with a lot of really neat things because you can use it to monitor all of your assets, in-house, other cloud providers, as well as Azure. So it's really try to do their best to make a unified framework around the whole process. So you have a one-stop shop to go see what your security posture is. So there's some security posture management that you really do want to look at, and they call it cloud workload protection. And it's basically a process or a solution that discovers all the weaknesses across your configurations, how you're set up, some code review, and help you protect your workloads across multi-cloud hybrid environments. There's a technology uses called XDR, which means Extended Detection and Response, and it really does take a look across the full computing environment, including your endpoints. They renamed this Microsoft Defender for the cloud when they did the rebranding to Defender. So kind of just so you know what the history on that one is. But it really is a neat tool to help you get your cloud workload protection going and that you can see everything that you've got going on. So the Defender for the cloud really improves your visibility. It will help you understand your current security situation, and it gives you a nice number. It tells you exactly where the problems are, and then it gives you hardening guidance and how to effectively and efficiently improve your security. So it not only tells you what's wrong, but it tells you how to fix it. If some of it is breaking, some of it is critical, some of it is important. So they kind of break everything down for you so you can actually plan out how you want to fix your process, fix your stuff, and improve your security. The central feature is that basically is a security score, and it's going to be 1 through 0 through 100. Most everyone's going to be around 98, 99 until something horrible happens, a 0 day, or something else happens with your code, or something happens with a configuration issue, or someone changes something and they weren't authorized to change something. So if your security score suddenly drops, you know that you've got an issue, and it will tell you what that issue is, and it will help you organize all of the ways to fix whatever that issue is, whether it's a patch, whether it's take away permissions for configuration changes from Johnny, just whatever you need to do to fix whatever the problem is. And it really does help you at a glance know what your current security process is. And the higher the score, the better off you are. So the lower the identified risk. The cool part is this will help you and your legal team do a lot of what's called due diligence. So if you're working in this environment and you're doing your due diligence, even if something horrible happens, you can at least show, but I was trying to do all the right things. And that goes a long way when you're dealing with your insurance and a long way with dealing with legal ramifications of a breach. So there are ways to use your security score. So one, you're going to generate a security score for your subscription based on your assessment of your connected resources, right? So there's going to be some Azure security benchmarks and some guidance that you're going to want to pay attention to. But that security score, it's just based on everything that you've got running at the time. And those are all through your subscriptions. Now, you can use that score to understand your security posture. Compliance dashboard is a great place to start to review your compliance and then use those built-in benchmarks. You may need different benchmarks and you can change these. The built-in benchmarks are just basically the baseline of where we think that you should be from that security viewpoint. Now, you can enable the enhanced security features that will be at a cost, and you can customize the standards used to assess your compliance. So you may have other things that you need to do. So you may need to pay attention to NIST 853, the Cloud Computing Security Framework, a lot more than someone else. You may need to pay attention to GDPR. You may need to pay attention to HITRUST and HIPAA, right? So there are going to be organization-specific security requirements that you need to pay attention to, and you can use the Security Center and the Compliance Center to help you get there once you've got the baseline taken care of. And this is a great way of helping you really get to where you need to be for due diligence. It will make your legal team really super happy to have that score and know what you did to get that score. Your legal department and your audit department will absolutely adore you for these things, right? So Defender detects threats, and that's its main goal. So it will detect Azure specific threats on the platform as a service level. So anything that's targeting Azure services, right, including app service, SQL, storage, data services. You can also perform anomaly detection on your Azure activity logs. So there's a lot of neat things here. The cool part is that anything that's passed in Azure is managed. So there's not a lot of things you need to fix. You may need to fix some of your code, but Microsoft will have their security team on this. As your data services, Defender for the Cloud includes capabilities to help you automatically classify your data. So data classification is a big one. It's really become quite the way of helping you manage risk around data and data management. So the payment processing information is super important information. You want to classify that as super important. Something simple like yesterday's grocery list is probably not so important, so it would be classified as who cares. So basically it allows you to classify your data in Azure SQL and to help you get assessments for those vulnerabilities that you may run into, especially depending on how much code you've written to access Azure SQL. And then there's networks, right? Limit exposure to brute force attacks, reducing your access to visual ports and other things along the way for virtual machine access, jump boxes, bastion hosts, hardening your network through network lists, NACLs, ACLs, and all those other things that go along with hardening your network. And then you can secure all your policies as well for selected ports. So if you only want to allow port 80 or port 443, you can do that. If you only want to allow port 443 HTTPS and not allow port 80, you can do that as well. It will really help you manage policies on selected ports, especially at your firewall, gateway, or access control or network control list or anything else you've got. And then authorized users, allowed source IP ranges or specific IP addresses, and then only for a limited amount of time. That's great for remote access, right? Especially if you have basically a cooldown area in your access, so we make sure that they've got all the antivirus installed and everything else, or if you've got MFA, two-factor authentication, anything else will help you with that network side of it. And then there's policy and compliance. So your audit department will like this one. Your policy and compliance is one of the largest benefits of this whole process, right? Because it gives you the insight and controls it provides over resources, either in a subscription or as a management group of subscriptions to the services that you're using. So control can be exercised in a lot of different ways. They can be used to prevent resources from being created in the wrong location, or just resources from being created by Jimmy. Because Jimmy shouldn't be making resources, but Paul should be. So you can manage it by enforcing common and consistent tag usage and making sure that people are doing the right thing, either by name, by group, by department, or by role, right? Or auditing existing resources for appropriate configurations and settings. These are great, especially if you have to have a third-party person come through. You'll get your data center audit directly from Azure. They'll say the data center is good to go. And then you can run this whole thing against your configuration and settings. And then boom, out comes your policy compliance. You did not spend weeks doing this. You spent an hour maybe letting the machine do the work. And then you're done. Your audit and compliance is set. And if something was wrong, you've got to fix it right on the bat. But you should be paying attention to this anyways. But in all cases, Azure policy will enable you to understand your compliance state of your environment. And this is really super important, not just for legal reasons, but for compliance, regulatory, and in case of a bad breach, due diligence, which will help you minimize the amount of damages that you'll pay in court. So new evaluations of security and compliance are triggered by events. So if something changes, right, you can actually trigger a new security and policy process. So policy states can be summarized for subscription and level, but can be triggered by program or by person. So you can actually press a button and go do it. Or if something changes, a configuration, a critical configuration changes. So your firewall changes, you change a rule on your firewall or something else, that can trigger a whole new thing to run for you, and then you don't have to worry about it. Policy events are triggered when something changes and can be reported up through the security center. So not only do you have policy, but you can also do this through the security center, and it's to a particular resource. Say you wanted to track your database, right? So you wanted to track whatever changes were happening to your database, or you wanted to track developments in the use of policy towards your database. Maybe you've got specific rows or columns encrypted. So again, there's neat things that you can do within that whole entire Azure subscription to make sure that your policy and events are taken care of as you go through and triggering that process through events. So you can also do evaluations of policies, right? So a policy or an initiative newly assigned to scope, it can take about 30 minutes for the assignment to be applied to the defined scope, but once it's done, the evaluation cycle starts, and you can check and see if that newly assigned policy works in the context of what you're doing with that scope. Right? A large policy or initiative evaluated against a large scope can take time, so there's no really predefined expectation of when that cycle completes. It just will complete and then let you know. The results are available either in the portal, or you can download the data through the software development kit and play with the data however you want. Report it out however you need to report it out. A policy or initiative already assigned to scope is updated. Again, if you've already got something in place, you've already run your baseline and you're making those changes, well, it's a change in scope, so we'll just run a new evaluation cycle. You can also set this up to be automated. So if you want to just do a quarterly, make sure that you're in scope all the time, run it quarterly. You can also do it when a resource is deployed, right, or updated within a scope via the resource manager. And this can be done through the API or through the SDK. So basically an event happened, an append, an audit, deny, or deploy, and a compliant status information changed. So you can get this about 15 minutes after the alert started, and this event doesn't call the evaluation of the other resources, just the one that changed. So that's a big one. And then more evaluation of policies. Again, your subscription is at the command line is Microsoft Resource Subscriptions is created or moved within a management group. With a different assigned policy, will be an event. So if that audit comes back as not exists, or deploy if not exists, modify, all that remediation can take about 30 minutes to happen. So if you move your Office 365 subscription from one resource group to another, you'll get a new policy run on that, because there may be different rules depending on the group. There's policy exemptions can be created, updated, or deleted. So in this scenario, the corresponding assignment is evaluated if it's exempt. Right? We don't need to worry about it because it doesn't do anything that falls underneath a legal or regulatory compliance portion of the day. Standard compliance evaluation cycle once every 24 hours if needed. Assignments are automatically reevaluated, and again, the larger the policy, the longer it takes to run. So there's no predefined expectation of when that cycle completes, but once it completes, you can get it via the portal or via SDKs. So guest configuration resource provider is updated with compliance detailed by a managed resource. So basically an on-demand scan. You can just go and boom, press a button and see if you're in compliance. And if you're not, it will tell you where you're not and then tell you what you need to do to fix it. So security alerts. These are probably the bread and butter of what we do, and just about anything with information security is something happens and we need to know about it, whether that's OS top 10, whether that's someone brute forcing our system, whether that's SSH happening way too many times, or in the case of Windows, a bunch of remote desktop try to log in through there. So anything that's triggered by advanced detection and are available only with advanced security features enabled, and you can upgrade this. So really, it's probably a big thing that you do want to do, is that you really do want to go to the advanced security features, especially the bigger you are and the more things you need to get covered, right? Especially if you've got regulatory or legal requirements. So alerts are notification that Defender for the cloud, when it detects a threat to your resources, it will prioritize and list the alerts. It will consolidate them up and then give you the information needed to quickly investigate them. So it will tell you that your Bastion host has had 1,000 attempts at trying to remote desktop protocol in. So someone's trying to remote log into that, and they're not coming from a place that you recognize. They're being geo-fenced off. So we don't know why someone from Slovakia is trying to log in to my system. So that will be a big thing. Your alert data is retained for 90 days in the system, but you can also move that over to a database and keep it for longer if you want to do longer trend lines. I'm a big fan of as much trend line as I can get, so I would take that alert data and move it to a database as well. So I would have longer than 90 days, but the 90 days is the minimum retention. Depending on your legal or regulatory status, some of this stuff needs to be kept for 7 years, and some of it needs to be kept for a lifetime. So that 90 days may not be appropriate. Just be ready to have a database handy in case your legal department says, I need these for longer. Right? A security incident is a collection of related alerts. So instead of listing each alert individually, it's going to roll these all up to an alert correlation, which is kind of nice, and call it an incident. And that will allow you to kind of differentiate between what is actually going on and any other things that may be circling around that security incident. So it's a nice way of branching everything together and making things ready for your forensics team to come in, or to support a forensics identity process for this. So you can actually kind of have a roll up here. So using incidents within Defender for Cloud provides you with a single view of an attack. And that's kind of neat, right? That's an unusual thing. Usually you only see that in security information management or security information enterprise management. So it's nice to have that. As a mid-sized company, you would not normally have these kind of tools to you, or even as a small company, you definitely would not. So this puts you in play with a lot larger organizations, and you're really taking advantage of Microsoft's security team, and as you should, right? This view enables you to understand what actions the attacker took, what resources were affected, and then what you need to do to fix it. And that's the big one, right? What do you need to do to fix it? So your security score, again, from 0 to 100, the higher the number, the better you are. And it's basically a heads-up display. It's my score is 98 today. Why? What's going on here? And it will tell you what's exactly going on, why you got that score of 98. If all of a sudden your score goes from 98 to 60, you're going to have a very busy day trying to figure out what happened and then having to go back and fix a bunch of stuff. So this is the central feature in this entire process for the Defender, is that it just allows you to have a score real quick and easy, and then gives you a bunch of things you can do to bring that score up. So Defender for Cloud will continually assess everything that you've got inside the Azure data center, right? So all your resources, all your subscriptions, organization for security issues. It rolls all those up into that single score so you can tell at a glance, and this is what's going on today. The secure score is shown in the Azure portal pages as a percentage value, but the underlying value is also clearly presented. And when we do the walkthrough on this one, you'll actually kind of see what they mean by that. It is a neat way of taking a look at stuff. And again, it's really intuitive. So if you're not a security person, if you're a manager or you're just working in someplace else, that security score number, again, super intuitive, really easy to kind of help you figure out what needs to be fixed or how to budget for being fixed, right? The best part about that, again, is that it gives you recommendations. It doesn't just say you have an XSS vulnerability. It tells you how to fix that particular XSS vulnerability, because these are not new things. We have decades of information on how to fix specific problems in the cloud, or fix them in specific processes in terms of programming and code development. So take advantage of all that background information. Right? Recommendations are grouped into security controls. Each control is a logical group of related security recommendations. So it is all about your vulnerable attack surface. So it will all be by your web server, or by your database, or by policy and compliance, or by users, or by code, or by whatever process you've got going. It will roll those all up to see how well your organization is securing each individual attack surface. You can review the scores for each security control as well. So you may be doing great in user management, right? You may have a score of 100 on that, but on your network configuration, you may have a score of 10. So you know where to put your resources, and that's the other really important part. You're not busy running around trying to fix stuff that is already fixed, but you can actually pinpoint and then go fix the things that really need to be fixed. And you can allocate your resources appropriately, especially inside, and make sure that you also can bring in your contractors or anything else you need to help you fix those things. And then we finally come to resource hygiene, right? So Azure Resource Health is basically helps you diagnose and get support for service problem that affect your Azure resources, right? So it is all about Azure status reports. It is the things that affect the broad set of Azure customers. So is a data center healthy? Is this SQL server in this zone or this region healthy? Resource Health shows all of the times that your resources have been unavailable because of Azure service problems. So it also makes it really easy for you to see if an SLA was violated and maybe you can get some money back. Because you have to ask for that. You have to ask to get your money back if something's out. So resource hygiene is really neat. That Azure status report is a great way of finding out if there's something on the Azure side, the Microsoft side, that impacted your operations outside of the SLA or longer than the SLA time of 99.95 to 99.99 downtime. Resource and definition, right? A resource is a specific instance of an Azure service, such as virtual machines, compute, web apps, SQL database, cognitive services. So it's basically the big, broad idea behind it. Resource health relies on signals from different Azure services to assess whether a resource is healthy. So if it's unhealthy, then it will mark it that way. If it's healthy, it won't. But it's a big picture item, right? It also reports actions on Microsoft is taking to fix the problem. And that's also handy if your management is coming down and saying, why is my database down? You can say, well, Microsoft boo-booed here and this broke and we didn't have a replica failover, but we asked for one, and maybe plan some resource management, because if you're only using one database in one zone, then you need to start planning on scalability and a little bit of disaster recovery and business continuity. All right, so in summary, man, this was a big section. There's a lot of things to the Security Center, but it is a neat tool to have at your disposal, especially the security score, understanding how all that ties into policy and compliance and audit and support for your organization, how you can work through your workflows to make sure that you, at all steps in your configuration and in your audit and compliance standards, you are meeting your due diligence, which is the big one. Whether that's your code, a service, or something that impacted Microsoft at the Azure level, you've got all that information in a heads-up display with a score, what to do, how to fix it, and where to go from there. So that's it for this section on Security Center. Again, it's a neat thing to go tour. You really should go tour your Security Center and kind of see what all the things they've got. You won't get asked a tour on it, but you will be asked just the generic basic things about the Security Center. What's in it? What does it look like? What does it do? And I think we covered that pretty well in this section. And I will see you in the next lecture, 4.3. So we're going to take a look at the Key Vault, and that is just another neat thing to have. Again, this whole section is just full of neat toys to go play with. All right, so your Azure Key Vault is your cloud service that safeguards your encryption keys and secrets. So your certificates, your connection strings, your passwords, the way that your developers are going to programmatically connect services together so that you don't have to embed usernames and passwords in code, which is really bad to do. Everything is going to be in Key Vault. It is a neat thing to have. It is part of the Microsoft Defender, and for doing Azure native advanced threat protection, the Key Vault is a really great way of providing an additional layer of security intelligence. And basically, it's just good best practice to have a way to manage all your keys. So Microsoft Defender for Key Vault will help detect unusual and potentially harmful exploits or to access or exploit Key Vault protected accounts. So your keys are really the keys to the kingdom. You're going to have service accounts that need to do actions on behalf of other chunks of code that will pass all these values back and forth. So that Key Vault is a highly protected item that you need to keep track of. Limited access, limited ability to change anything in the Key Vault. If someone needs something from the Key Vault, you should give it to them. Just that, not the whole access if they need a service account or something else. So this layer of protection will help you address threats even if you're not a security expert, and without the need to have a third-party security monitoring system, because it's all basically going to be rolled up into that Key Vault process. So what this process does, what Key Vault does, is when an anomalous activity occurs, someone's trying to pound into a service account or someone's trying to brute force their way into something else, Defender for Key Vault shows alerts, and then you can send them to you via email, to members of your organization. You can also do it via text messaging if you have the text messaging gateway up and running. And it basically is going to include details of the suspicious activity and recommendations on how to investigate and remediate if the threat looks real. So if you get an alert from Microsoft Defender for Key Vault, they will recommend that you investigate and respond to the alert as described and respond to the process. There's a whole book on how to respond to these things out there on the Microsoft site. So the big thing about this is that this protects the application credentials. So code to code, service account to service account, service account to code. That's really the important part. And usually these are unmonitored, unmanaged, unmaintained. They may never even have their passwords changed, but they have a big permission set. So you may have a service account that's got a lot of permissions because it needs those, but now you have a way of checking and seeing if someone's trying to break into that service account and do something nefarious with it. So secrets management, right? Key Vault protects all of your secrets. Azure Key Vault can be used to security store and tightly control access to tokens, passwords, certificates, API keys, and other secrets that you do not want on the street. So it's keys to the kingdom, right? Key management, you can use this as a key rotation, key update, key process, key management thing. You can do all the life cycle around your keys using key management and the Key Vault. It makes it easy to create, control the encryption keys used to encrypt your data. Right now, the other thing too is if you are encrypting data, you definitely want to keep your keys backed up here and backed up other places as well. The other thing, certificate management, Azure Key Vault lets you easily provision, manage, and deploy public and private TLS and SSL keys, HTTPS keys, so all the other keys that you need to have to make sure that all your stuff runs correctly when you're working with security, VPNs, any kind of security tunneling across the network or anything else. It's all there. There are two tiers to this: standard, which encrypts with a software key, and a premium a premium tier, which includes a hardware security module, so HSM protected keys. There's a big comparison on the Azure Key Vault pricing on how that works. Depends on how much service you buy and how do you buy them, and how much time you're willing to keep up these things or the other things you need. So really that Key Vault pricing is really variable, and depending on what you buy for standard and premium tiers, the prices range all over the map. But the big thing to remember is that there's two tiers of service: standard, which is a software key, and premium tier, which is a hardware module that goes into this. So in summary, right, the Key Vault process to protect and monitor service accounts. And that's important because your service accounts usually have a lot of permissions and will get to do things that you may not want a user being able to do if they break into that service account. There are two tiers, standard and premium, and prices are all over the map, so just be aware of that. Secrets management, the Azure Key Vault can be used to securely store and tightly control access to tokens, passwords, certificates, API keys, and other secrets that you may have in your installation. Key management, again, can be used as a key management solution to rotate keys, update, deprecate keys, and create and control the encryption keys that are used to encrypt your data. And then certificate management, again, lets you easily provision, manage, and deploy public TLS and SSL certificates for use with Azure and your internal connected resources. So this is a neat thing. You can cut your developers or your system administrators their own SSL key, and they can SSH in and without a problem, or use that for their RDP, depending on how you set up your backbone. So Key Vault is a neat system to have. It does an awful lot of stuff to make sure that your data remains secure, provides some limited monitoring and management of alerts and everything else. So you do want to pay attention to who's breaking into your service accounts or trying to. And again, this is just a great way of managing keys internal to Azure, and you don't have to have a third-party service do this for you. So that's it for this lecture. I will see you in the next lecture, where we're going to do a little bit talking about Azure Sentinel. So Azure Sentinel is basically a cloud-native security information management system. It is a great way of dealing with all of your security information event management and security orchestration automated response. So Sentinel is basically your intelligent security analytics. It's the robot that's helping you make sure that it has a solution and is seeing alert, threat, proactive hunting, and threat response. So Microsoft Sentinel is your bird's eye view into the enterprise. And again, you're leveraging Microsoft's security department with a lot of this stuff. So this is a big thing to have, especially if you're a small, medium-sized company. This gives you access to security tools that you would otherwise not have. So again, Azure Sentinel is basically your security and information management system, right? and part of your security orchestration. So there's basically places where it goes here and how it works. So collect, detect, investigate, and respond. So it's going to collect data at cloud scale across everything you've got, across your entire environment, and then basically dump it into a database and mine it. It's really neat. It will detect previously undetected threats and minimize false positive. It uses analytics, a lot of AI and machine learning on that to help you with that process. So it's nice to have your own model for how your environment works. That is like a holy grail of stuff. I would love to have had this in my information security career. Investigate those threats with artificial intelligence. Usually generally you're trying to figure out, is this live, or is this something weird, or is this just someone blowing through the system, just a general automated scan. That investigation with artificial intelligence will really help you minimize the noise, because there's a lot of noise in the background on the internet. And you get to tap into years of cybersecurity work at Microsoft. They are really good at what they do when it comes to this. So it will allow you to hunt, find, and then determine whether if it's bad or if it's just a bunch of kids playing around. So then respond appropriately, right? And that's the big one, because it's really easy to go crazy and go, oh my God, we're all going to die when you respond to something. But again, responding appropriately to a security incident is a big one. And it will allow you to do a lot of stuff with built-in orchestration, automation of common tasks, whether you need to make a forensic analysis, whether you need to do something else, or just lock down a port. It's all there in terms of you get to choose how you want to do this. And it will do it automatically, or it will do it with you pushing a button and being the oversight part of it. So you can respond intelligently. And that's a big one when it comes to information security. Responding appropriately without flipping out. So what it can monitor out of the box, again, Microsoft Sentinel connectors for all the Microsoft solutions right out of the box. Microsoft 365, Office, Azure, Defender for identity, just everything, right? So it's all nicely tied into all the other connectors that you would have. There are built-in connectors for broader security, right? So you can also use syslog, REST APIs. So if you pull your logs from your routers, from your virtual switches, you can actually use the syslog format and dump it all into the database, connect your database and your data sources. If you want to connect this back into your data center, you can certainly do all that. And Microsoft Sentinel, again, is a great way of just working out part of the process along with the rest of the things that go along with this. You can also do workbooks. Now, workbooks are kind of a neat process when it comes in here, because you can connect all your data sources and then monitor that data and then turn it into basically a workbook, which is basically allowing you to do your heads up display. Basically, this is my workbook for this process. And these are the things that I'm going to display in that. So it's how you're going to do displays for real-time monitoring, real-time logins, real-time hacking activity, real-time usage, what systems are working harder than others. There's a lot of neat things that you can do here. If you have a really good professional data analysis person working with you, there are cool things you can do here. You can create some really beautiful interactive reports using the Azure Monitor. So Microsoft Sentinel allows you to create those custom workbooks across your data. And again, if you have a really good data analysis person, data designer, data programmer, you can really make some beautiful heads-up displays that will allow you to quickly gain insights across how your data is working and why it's working the way it's working, and if something's not working right, if someone's trying to do something weird. So Sentinel has got a big base in machine learning. So it'll help you reduce noise and minimize the number of alerts. Microsoft Sentinel uses analytics. And again, this is why you really want a good analytics designer for this. Everything is grouped. You'll see that as a really common thread. Everything is grouped and rolled up, and then basically processed to make sure if it's real, or if it's just a false positive, or if it's just possible threat instead of a real threat. You can build your own correlation rules, or you can just take the rules as is as a starting point and build your own on top of them. There's a lot of places you can go here. So Microsoft Sentinel and that machine learning rules to map your network behavior and look for anomalies across your resources. If all of a sudden you're moving gigabits of data at 2 o'clock in the morning and you never did that before, that's something important to note. And need to go back and figure out why you're moving all of a sudden your database 2 or 3 times each night off of your cloud provider process, and make sure that it's really legit for what you want to do here. So analytics connects the dots. All right, low fidelity alerts with different entities to potential high fidelity security incidences. It's a really neat thing that's really hard for people to do by just looking at a bunch of log files. Automation, automate your common tasks. This is big. This will help save your security folks and give them time to actually move on and take a look at bigger issues within the organization that need to be done. So instead of chasing their tail every day looking at common events, you can orchestrate via the playbook, integrate with your Azure services, and then move on and actually really provide a lot of value to your organization, and they'll be working on top of Microsoft security. So all of a sudden your security department just got like really supersized because now you have a lot more data and you have a lot more things that you can do with it by using Sentinel. Right? It's going to be all built on the foundation of Azure Logic Apps. It's all automation orchestration solution. Is really common to the internet. It's really cloud native in that regard. And again, it's scalable. It will do all the things that you need it to do. And then when you build in playbooks, you can actually go ahead and start seeing how your data will be visualized, because that's how we're going to process this better. There's 200 different connectors right now for Azure Functions. There's a lot of extra custom logic and code, and right now you can work with ServiceNow, Jira, Zendesk, HTTP, log files, Slack, and a lot of other things. So it's basically turning into a really good Swiss Army knife of neat things to plug into your security posture just to see where you're at. Your legal team and your audit team will love this. So, and your security team will absolutely love this because it frees your security team up from the drudgery of log file analysis and into actually really taking a look at what's going on in their network. Right? It really frees them up to do a lot more neat stuff. So again, this is Azure Sentinel. It manages and monitors all your security events. It can use AI and machine learning to process requests. And again, it works with just about every Azure service and a lot of other services along the way. It gives you a big picture of what your security posture looks like across the board. And it's an important tool to really use. You're building on top of Microsoft security, and they have got decades of top-notch, top-flight, good security. And this will definitely help your security group out a lot in trying to figure out reducing the noise, the day-to-day drudgery of log file analysis, and really get into the cool things that are part of information security. So that's it for this section on Azure Sentinel. I will see you in the next lecture. Information security is dedicated hosts. Now in section 4.5, we're going to be talking about dedicated hosts in the Azure context. So what are dedicated hosts? So a dedicated host is a service that provides a actual physical server to host one or more virtual machines, and is dedicated to one Azure subscription, right? So it's the same as the physical server used in your own data centers. It's provided as a resource. So you can use this as a jump box. You can use this as your VPN gateway. You can do this however you want to do it to provide a little bit more security for your access and for your systems, right? You can provision that dedicated host within a region, an availability zone, or a fault domain. Right, and you can place the VMs directly on your provision host or whatever configuration best meets your needs. Most people will use this as your security bastion jump box to get into the back end from a remote location, especially if you have to do systems administration and you don't want to go through the portal. Right, there's always ways around this. Again, a lot of the cloud really requires that you rethink how you do work. So you can do a lot of things through the portal, but there may be sometimes you need to go through jump box and you may need to do something at the command line. So that's why you would have this. So hardware isolation, this is a good one. Hardware isolation at the physical server level. So for those things that you actually need to have that service for, it's available to you. Dedicated hosts are deployed in the same data center, share the same network as other non-isolated hosts, but it is its own computer. Control over maintenance events initiated by Azure. A lot of stuff will actually happen without being really impactful to your virtual machines, but there are some sensitive workloads, so each second of pause can have an impact. So you can opt into a maintenance window to reduce that impact of your service. So there are things that Azure is going to do to make sure that they're taken care of. They're not just going to let you run some unsecured, unprotected system out there. They will take care of that for you because that is their responsibility. So they will work on a maintenance window if they need to, but either way, they will fix things. So with the Azure hybrid benefit, you can bring your own licenses as well. So that's nice. Using the hybrid benefit will help you bring your own licenses to Windows, SQL, save you some money along the way for that dedicated host if you need to go that route. Then finally, you can actually put these things in host groups. So a host group is a resource that represents a collection of dedicated hosts. So you can have them all in one control plane, which is nice. And you can create a host group and a region and an availability zone and then add those particular hosts to it. This is a really expensive option to take, right? So make sure that when you're doing this host as a resource and you're mapping to a physical server, that the physical server is allocated when the host is created. You will pay for that a lot all the way through. So make sure that you get exactly what you need and you have a very clear reason for needing to have your own dedicated host in the Azure data center. Because you may not need it. It just all depends on why you need it, what legal or regulatory requirement you need to have, or what super secret security you need to have, or something else. Because it's going to be a fairly expensive process to deal with along the way. So availability zones, just to kind of reiterate, we've talked about these earlier. Unique physical locations within is your region. So you have the region, so the region may be Virginia, and then that availability zone are the 3 different data centers that are in the Virginia region or area that have whatever they need. Each zone is made up of 1 or more data centers with independent power, cooling, and networking. Again, we saw all this in section 1. But when you assign your dedicated host to an availability zone, all the VMs created on that host must be in the same zone. So you do miss a little bit of failover, you do miss a little bit of flexibility with that dedicated host. So just so you know that in that availability zone, anything you make on your dedicated host must remain in that same zone. You can't move it around. You can also use this for fault domains, for fault isolation. So this is a unique way of kind of taking a look at specific fault domains within your virtual machine and within your dedicated host setup. So just like in a virtual machine, you can scale or set availability. Hosts in different fault domains can be placed on different physical racks in the data center. So you can specify 1 data center, 2 data center, 3 data center. You can actually, in some cases, maybe place it in a physical rack or treat it as a fault domain. So when you create your host group, you are required to specify the fault domain count. So when you're creating your host within the host group, you assign your fault domain to each host. The VMs do not require that, but your dedicated host does. So by assigning a fault domain, you're basically saying, I want 1 in rack 1, I want 1 in rack 2, and then I want 1 in this other zone in rack 3. So you can actually have that level of control over placement. And that's nice in case a section of the data center goes down. The whole data center doesn't go, but something in it does. Then you've got that as a fault domain. And again, this is going to be for stuff that absolutely critically must be operational 100% of the time, for super secret or for telecommunications, something that really does require that level of uptime. So fault domains are not the same as co-location, right? Understand that. Having the same fault domain for 2 hosts does not mean they are in proximity to each other. Fault domains are scoped to the host group, so you should not make any assumptions on any kind of affinity or anti-affinity between 2 different host groups unless they're in different availability zones. And then any kind of VMs that you deploy to your dedicated host with different fault domains will have their underlying managed disks on multiple storage. Right, and that will increase their fault isolation protection, but the way that they're going to do it is they're going to try to set it up so that if something goes, you do have a failover position to begin with. It's not just all or nothing. So when you're using your availability zones and default domains, you can use the capabilities together for really good fault isolation. And this is going to work if you have something that you need that with, right? Something that's telecommunications or something that's super secret. That fault isolation is important. You will need to specify the availability zone and the fault domain for each host group. And that's important as well. So that you can make sure that you're assigning an availability zone to each of your VMs. Then finally, in your host groups, your basic process is going to be select, make, and host. So select, when you're creating your VM, you can select which dedicated host to use, where to place it, how to work it, what to do with it. You can make your new host group, make sure that setting works for your automatic VM placement, and then the host is enabled for automatic placement so that VMs that don't need it don't have to deal with it. So that's a really big one on this process, is that making sure that you've got all this stuff set up. So Azure Dedicated Host is a service that provides physical servers. It is able to host 1 or more virtual machines. It is dedicated to one. It's your subscription, but that doesn't mean that you can't have them in other availability zones or other regions. So dedicated hosts are just physical servers, and they're as your data center, right? And it's just a resource. You can provision these within a region, an availability zone, and a fault domain. So that's important. You really do have a lot of control over where they go up to a certain point. Then you can go ahead and place your VMs on those provision hosts in whatever configuration best meets your needs. This is a really expensive option. You need to make sure of what you're doing and why you're doing it if you're going to go with dedicated hosts. There has to be really good business logic behind it, either something super secret or something super sensitive or something extra super legal or something else to make this cost effective for you. There has to be a very specific reason for that. So definitely, if you're going to go this route, make sure of what you've got in terms of using dedicated hosts in such a way that is cost effective for your organization. And that's it for this lecture. This is section 4.5 covering dedicated hosts, and I will see you in the next lecture. Section 4.6, network security. Network security is one of those things where there's whole chapters and books and processes around how network security works, both in the cloud and outside of the cloud. So just for this test, for the AZ-900, really, when they go into it, all you really need to do is be able to describe it and do a little bit of discussion of it. You kind of need to know where things are, but you don't necessarily need to know everything about network security or cloud network security. That's a whole other discipline along the way. So this isn't an in-depth review of cloud network security. It's really more geared towards what you need for the AZ-900 exam, the Azure Fundamentals test. So I just kind of want to get that out of the way because we could be here for the rest of my life talking about cloud network security and having a good time with it. So generally, what is network security? It's basically the process of protecting resources from unauthorized access or attack by applying controls to a network traffic. Control can be a firewall. A control can be a network ACL, a firewall, port blocking, and there's a lot of other controls you can put in there, both technical and policy, right? So you can have a policy that says because we're PCI DSS, a firewall has to have these settings. That would be policy. The technical control would be actually implementing those settings to meet that policy, right? The goal is to ensure that only legitimate traffic is allowed onto the network, and that's fair enough. We don't want bad people on our network doing stupid things. So Azure includes a robust networking infrastructure. So that's the one thing that you really do want to leverage as part of this whole network security port. Is that you're going to be leveraging Azure, you're going to be leveraging the Microsoft security team and the Azure security team. This is an amazing ability for you to learn a whole lot about working with other groups and learning about what really matters when it comes to security. And then the thing to remember too is that network connectivity is possible between resources located in Azure, on-premise in Azure, and then from the internet to Azure. So you're getting traffic from everywhere. There really is no edge or defined boundary anymore. It's just the consumer, your app, whatever process you've got going along with that for your business logic. Now there's a lot of components to this, and we're just going to cover some of those, especially ones you need to know for the test. But one of the things they were very clear on in the syllabus was that you just need to know what these are. You don't need to know necessarily how to configure them. You don't have to know how to build them or anything else. You just need to know that they exist and what they do. So is your networking, again, that's your ability to connect computers together inside and outside of your network. Network access control, the firewall, secure and remote access, availability, name resolution like DNS, perimeter network, any kind of DMZ architecture you may want to have, any kind of denial of service protection, is your front door process, the traffic manager, monitoring and threat detection. These are all components. These are all things that go into building out your network security, and you're just kind of stacking these things together like Legos and then connecting them. So really how this works, right, is that you've got virtual machines that are connected to a virtual network. All right, so basically it's still not physical yet. It's all just bits and bytes. A virtual network is a logical construct built on top of the physical Azure network fabric. So sort of like a VPN or a VPC, you are working within just the network that you build for your stuff, right? And this helps ensure that network traffic in your deployment is not accessible to other Azure customers, either by design or by accident. So if someone puts up a sniffer, maybe a little bit of TCP dump, old school kind of tools, that will work really, really well in this environment, that they're just looking at their traffic, not at someone else's traffic. And that's important because when you do your virtual local area networks, you do your virtual private clouds, you do all the other things that go along with this, it all has to ride on that virtual network. So part of that is that you get a network security group. You know, the thing you want to remember is that they are stateful. and that they're packet filtering, and it's basically a little simple firewall. So the network security group, it just enables you to control access based on a 5 tuple. All right, so that's not important. Just remember that it's a network security group that's stateful and packet filtering. It includes functionality to simplify management and reduce the chances of configuration mistakes. So we have those. And then we have application security groups. Application security groups allow you to deploy resources to application groups and then control access to those resources by creating rules that use those application groups. So if you have web servers, you can make a web servers application group that creates a rule that only allows port traffic on 443 HTTPS and no other ports, which is great. If that's all you're doing, you need to have a way to get around and be able to manage those web servers as well. So there'll probably be some other ports, but you could have a network security group that allows from outside to port 443, and that's it. And if you're inside or from a jump box, that you can use other ports along the way. So the application security group is kind of important and a great way of logically breaking out all of your applications. Then there's your service endpoints, and these are another way to apply control of your traffic. You can limit communication with supported services to just your VNets or other direct connections. So traffic from your virtual network to a specified Azure service remains on the Microsoft Azure backbone network. So if you want to have your web service only go across a specific VNet to specific system, like a system load balancer, that's it. That's all you would have to do. Or you could send it to a web application firewall, everything. And then from there, have another section, and then from there, have another section. You can break things down into how your endpoints all intercommunicate with each other. Routing behavior. This is important too, because the ability to control routing is kind of important for your network. And if routing is configured incorrectly, your systems will really slow down. Or you might connect to unauthorized devices. There is one of the things that's interesting about that is I worked out at a company once, and they were all trying to figure out why they were having such problems logging in to the network. And they kept on trying and they weren't able to get in. So we put up and we took a look around, and we came up on wireless, and we noticed that someone had put up a similar named access point, right? And they were collecting credentials off of the employees. It was within range. And that was interesting, because then we had people connecting to unauthorized devices. So you really want to make sure that you're connecting to your own stuff, and the ability to route traffic is important for that. Azure Networking supports the ability to customize the routing behavior for the network traffic on your virtual networks. So that's important through ACLs, network access controllers, firewalls, and all the rest of it. You can literally segregate your systems down by what they do, how they work, or what ports they allow in. So this control of routing behavior allows you to make sure that all the traffic from a certain device or group enters or leaves your virtual network through a specific location, or through specific locations, or through CDNs, or whatever. There's a way of making this work better for you in terms of managing how traffic is balanced in your network. So your network engineer will have a great time working out how routing behavior works in the cloud, especially since it's all virtual. Another thing that's interesting too is something called forced tunneling. This may or may not be on the test, but it's something that you do want to know, is a mechanism you can use to ensure your services are not allowed to initiate a connection to devices on the internet. So generally what should happen is that I will make a request to a web server, and then the web server will respond to me. What's bad is when the web server responds to me long before I ever know about that web server existing. So generally that means that there's something wrong with that web server. Either it's been taken over or something else. And if you end up having something taken over, then your hacker is going to come from a system and initiate the connection to their drop point. So this forced tunneling, make sure that that can't happen. So this is really good protection if you have a system that's been compromised. It doesn't allow that system to initiate contact with the bot herder or the drop point for the data or anything else. So this is really kind of important to note, that this is different from accepting incoming connections, but forced tunneling you can use to ensure your services are not allowed to initiate a connection to devices on the internet without being done first. So that's important to know about forced tunneling. Then there's a bunch of additional services. So there's a lot of ways of controlling the network and the data that's on it. So you have authentication and authorization before allowing access to your application. I have to log in. And that's a whole subset right there. Intrusion detection and intrusion response. There is actually intrusion detection in your Azure Defender, your Azure Cloud Defender process. to take a look at how you respond to intrusions. Application layer inspection for high-level protocols. You use your web application firewall, or you use other kinds of firewalls like that will actually take a look at what's going on with your requests to your data. Then URL filtering, good URLs, bad URLs. Make sure that things like OS top 10, especially URL rewriting, can't get through. Network level antivirus and anti-malware, that's pretty straightforward. You can just plug that in. And then anti-bot protection, application access control, traditional denial of service protection, and that's some of that's provided by Azure itself. And then there's the enhanced network security features by using an Azure partner solution. So there's a lot of things you can do that will add up to really doing a nice job with your network security. Then you have the Azure Firewall. So I really like the Azure Firewall. It's kind of neat. It's a managed firewall, cloud-based security service that protects your virtual network, right? Fully stateful and built-in high availability, cloud scalability, fully qualified domain name filtering rules so you can block things out, and then network traffic filtering rules. So it's like any other firewall. It's really good to work with, and it's really good to get to know. But again, the idea there is make sure that you know it's a managed cloud-based security service and that it's stateful. Then you also have remote access. So generally for your administration and everything else, you are going to have some kind of remote access to your cloud, whether that's over a command line or whether that's a remote desktop or however you want to do it. But you will want to connect individual workstations to that virtual network, connect your on-premise network to a virtual network with a VPN, connect your on-premise network to a virtual network back to the Azure data center, peering, or connect virtual networks to each other. There's a lot of things you can do inside the Azure environment to connect remote access. It's fairly straightforward and easy to do. It just depends on how you want to do it and based on how your legal team and your regulations tell you need to do this. So in summary, though, there's many ways of securing your network, and the big ones to remember are network security groups, virtual networks, the Azure Firewall, forced tunneling, and then remote access. And these are the ones that you'll probably see on the exam. So definitely do take a look at those and understand what they are and be able to describe them and when to use them. Other than that, that's it for this lecture, and I will see you in the next lecture. Section 4.7, Defense in Depth. So defense in depth is not a new idea. It's a really old computer security idea. It's been around for a super long time. And basically, this section, we're just going to identify the concepts of defense in depth and then identify some key technologies to kind of help you understand how this works. You're just going to discuss things. And again, like with the rest of this test, there's no build, there's no deploy. It's all about discussion and being able to understand what they're about. So defense in depth is just this kind of interesting way that we want to look at how do we want to trust and how do we want to build out roadblocks for hackers that get into our network. The new model that we're using here, especially as it gets into the cloud, is what's called the zero trust model. And this actually came from Forrester Research, and that you should never assume trust, but instead continually validate. And that means I'm not going to trust you. I'm never going to trust you, but I need you to be on my network, and I need you to be able to do things. I need you to be able to shop, or I need you to be able to buy a product, or I need you to be able to look at data. So when the user's devices and data all resided inside the organization firewall, you could trust them to a certain point, right? You could trust your employees. Now, the problem is that because of the way the cloud works and because of the way that we have built our internet, is that anyone can access anything at any time. So we can't assume trust at all anymore. So there's way too many ways for hackers to get in, and we need to just take a look at making sure that all of our systems have got processes in place to make sure that malicious hackers can't get in or can't do a thing. So under the zero trust model, most users now access applications and data from the internet, and they do using their own devices. So you can't trust the device. Most components of the transactions, the users, the network, and the devices are no longer completely under organizational control, so I can't trust that either. So the zero trust model relies on verifiable user and device trust claims to grant access to organizational resources. So it's no longer assumed, you have to prove it. And that's a big change in how we think. You can't assume the good intent. You have to prove that you have good intent. And we're trying to do this as far away from the critical data as humanly possible, whether that's at the perimeter, whether that's at a separate network, whether that's at inside the organization. You have to log into the organization first before you can get into the cloud assets. There's lots of ways of making the zero trust model work, but that's a big part of defense in depth. So with that idea of the zero trust model, defense in depth is a strategy that employs a series of mechanisms to slow the advance of an attack. We're never going to stop it. We've realized that at this point. We've been in computer security now for almost 40 years. A little bit longer than that. So what you want to do is you want to have each layer providing its own protection, so that one layer is breached, the subsequent layer is already in place to prevent further exposure. And that's the real big part of this, right? Is that each layer is protected, and that each layer has its own separate lock and key set to make sure that a hacker has to jump through multiple hoops to get to the really good stuff before they can get to the data. And that's where defense in depth really comes in. So part of this is based on an old school, really old school process called the CIA triad, and not our friends in DC, but basically how do we want to make sure that data is available? So we want to make sure that our data has confidentiality, and that the principle of least privilege restricts access to information only to individuals granted access. And that can include protection of passwords, remote access certificates, crypto keys, email content, anything like that. So we want to make sure that the data that we have is confidential. Then integrity. The goal is to prevent unauthorized changes to information at rest or in transit. So we're going to use crypto, we're going to fingerprint the data, we may do hashing, we may do a bunch of other things to make sure that the data wasn't changed in transit or at rest. And that's important. If it has been changed, we need to have a mechanism to roll back to that state where we know the data is authentic. Then we need to make sure that everything's available, so that the services are available to authorized users. So you'll log into Amazon or you log into Macy's or wherever, and you know that you are now an authorized user to go shopping at that store online. So part of denying people that ability to go shopping is denial of service attacks, and that's a normal common cause of loss of availability. Natural disasters, bad drive design, bad system design, bad architecture, bad failover, people cutting fiber optic lines. Any single point of failure or deploying multiple instances of an application that did not go right, all of that can affect availability. So availability is really big, but it really does take a look at not just authorized users, but looks at that whole multi-spectrum of things that can take down your application or take down your company. And that these are things you need to plan on either through architecture, through policy, or through controls. So neat stuff. So there are security layers, and these are the things to remember. And a lot like the OSI model, when you're taking a look at it, we do have our own model now for security layers in the cloud. And the first layer is the data. That's the core stuff. That's really what we want. That's where all the cool stuff is. That's where your credit cards are, your shopping behaviors, anything else that you've got as data for you. The application that uses it, the compute power that processes it, the network that transmits it, the perimeter that keeps it separate from the regular internet, any kind of identity and access to prove who I am, and then physical security. I can't just go waltz into the data center and say, I'm in charge here. So those security layers actually really matter. They're all important to kind of keep your system up and running. And you can put individual controls, either logical, physical, or technological, in here and make it happen. So data is the key to the kingdom. This is everything that everybody wants. This is the one thing they steal when it comes to a data breach. So it's all either stored in a database, it can be stored on disk, it could be stored on network attached storages, it can be files, it can be videos, it can be music, it can be anything of value that's data, right? So it can even be the documents you write in terms of Microsoft Office 365 or other things. So it can be stored in cloud storage. There's some really interesting walks you can do inside of cloud storage and see where people left their data wide open. There are some very large professional sports companies that accidentally left their data open, and people were able to pull down big sports contracts and see what people were getting paid from those big sports contracts. And that was quite the ruckus when that ended up happening. So people who store and control access to the data are responsible for ensuring it's properly secured, but sometimes you need a little bit of help with that, and that's where the security center and the trust center can come in. Your cloud defender can come in and make sure you've got a lot of your stuff set right for what you need to do. Often we deal with regulatory requirements that will dictate those controls and processes as well. So we need to make sure that we are working within our regulatory or legal requirements to ensure our CIA triad, our confidentiality, our integrity, and our availability of the data. Then applications, all right, so this is actually the software or the stuff that we use to process that data. Ensure that applications are secure and free of as many vulnerabilities as possible. Applications are written by people, so we know that there's going to be issues. There will be vulnerabilities, just because that's how we work. You want to store sensitive application secrets in a secure storage medium, and we talked about the key vault earlier, and that's a great place for application secrets, a great place for application credentials, and so that it's not just buried in code, because you never want that. Make security a design requirement for all application development. And this one's hard, right? Because your security people aren't necessarily programmers, and your programmers aren't necessarily security people. So you have to have that synergy between programmers and your security people. It has to be there to make this work. Otherwise, things will slip through the cracks. And then you need to integrate security into the application development lifecycle. You know, everyone's going to encourage that this happen and that we make security requirements non-negotiable, but then we all know the reality of deadlines. We know the reality of going to market. We know the reality of gold disk. We know the reality of security has got 12 hours to work with this application of 1 million lines to see if it's secure or not. Security is nine times out of 10 a bolt-on, but it's that 1 time out of 10 where you really need to make sure it's part of it. Cloud security really makes it a lot easier, because there's a lot of things you can put in the way for making sure that developers code securely and allowing access to the security people to the raw code. And make sure your security people are coders and your developers are security people. Make sure there's a synergy between those two things to make sure your applications are really, really good to go. Then your compute power, these are your virtual machines. Make sure you've got secure access. Make sure you're implementing endpoint protection, system firewalls, big firewalls, that you have all of your system patches in place, that you've got anti-malware on it, antivirus. Make sure that you've secured your system down to the minimum ports that need to be open. There's a lot of things you would do on that system administration side with compute, is to make sure that your compute resources are secure and you have proper controls in place to minimize all the security issues that come with the compute side of the house. Then finally, networking. Limit communication between resources through segmentation and access control. So make sure you've got your virtual private clouds. Make sure you've got your VLAN set up. Always deny by default. If everything breaks, make sure everything just shuts down, because if everything breaks, there's something weird going on and you don't want your data wide open, right? You really do want to restrict inbound internet access to just the systems that it needs to have. So that's going to be your system load balancers, honestly, or your firewalls. And those are really the only things that should be really honestly exposed to the internet. Everything else should be back behind either one of those two things, depending on how you've got it rigged on your network. You should never have a web server directly connected to the internet. There should be an intervening device between it, whether that's a firewall or a system load balancer. Right? Implement secure connectivity for on-premise networks. So make sure that you're either peered or you're VLANed or you're networked between Azure and your network on an encrypted tunnel, right? Whether that's VPN or however you choose to set it up. That is entirely up to you and what you can afford to pay for that. And at this layer, the focus is on limiting network connectivity across all your resources. You really do want to segment things. You want to have, think about your network as a grocery store, you want to have the meat department, the vegetable department, the cold department, the dry goods department. And that's really how you want to segment your resources and use network level controls to restrict how these all communicate back and forth to only what's needed, right? And you really want to make sure that you're limiting communication to reduce the risk of lateral movement throughout your network. You never want someone just to have all of the keys to your network. Then there's perimeter. use a distributed denial of service protection, and there's a lot of that built in. There's a standard service that you can just, it's on all the time. Perimeter firewalls to identify and alert on malicious attacks. And at the network perimeter, it's about protecting yourself against network-based attacks. So scans, denial of service, any kind of three-way handshake breaking, so SYN-ACK, anything that goes along with that, trying to identify these attacks by eliminating their impact and alerting them when it's important. So if someone's coming in and telnetting in on port 25, you want to know because they're trying to banner grab. So that perimeter is really super important in terms of how you do it. And again, it's really simple systems. We've been protecting the perimeter now for 30 years, right? So we've had firewalls and things like that for a really super long time. Identity and access controls. So you want to make sure that who you are is really who you are. So single sign-on, multi-factor authentication. If you're going to sign on as an administrator, you make sure you not only have a username and a password, but you have a device, a multi-factor authentication, whether that's email or phone or text, to make sure that I'm really me. You want to audit all the events and changes. Something comes along and all of a sudden you see a bunch of weird activity on your network, or you see a bunch of activity and ramping up new resources and new systems that you don't recognize or don't need or don't want. Go back and audit those. Find out what's going on. And then make sure that your identity and access layer is ensuring that identities are secure, right? That you have administrators in a very specific group, regular users, and then unauthenticated users, your customers, are granted access to only what's needed. And that any changes to anyone's permission set are logged and, if needed, auditable. Make sure that everything can be audited, right? And then finally, the physical security. This is one that you won't have to deal with as much with Azure, because you will never have access to an Azure data center. So the physical building security and controlling access, that's all going to be Microsoft. And they are very good at doing this job. They have little biometric hand readers, they've got the badges, the cards, and in some cases you actually have to make an appointment to get in. You have to be there at a specific time. So with physical security, the intent again is just to provide physical safeguards so someone can't just go waltz into your data center, put up a sniffer, and start doing cool stuff. So we want to make sure that layers can't be bypassed, and basically this is all on Azure to make sure that that physical security system happens. So we all work with what's called the shared responsibility model, and this is where the customer is responsible for their data always, and depending on what service you use, whether that's infrastructure, platform, or software as a service, you then also share that responsibility for the application or the platform or the full kit, except for the virtualization layer on down. It still belongs to Azure, but everything above that can belong to you for infrastructure as a service. That shared responsibility model is really kind of important when it comes down to what are you responsible for and what is Azure responsible for. And then there's always room to improve. So threat landscape is evolving real time. Always, every day there's something new. Hackers are very good at what they do. And Microsoft and its customers need to be able to respond to these threats intelligently, quickly, and at scale. And this is why it's really important for you to be in this environment, whether it's here or at some other third-party provider, because defense in depth really relies on data. And these cloud service providers have a boatload of data on how this works, what the threat landscape looks like, and they share it with their customers. So you know what they're seeing, and that's important to help you make really good decisions when it comes to your software and your program. So the big thing to pull away from this is to understand the 7 layers of defense in depth and how they work. So go back through and review data, application, compute, network, perimeter, identity, access, and physical security. Make sure you're comfortable with all those. Make sure you understand the idea behind defense in depth, maybe a little bit of CIA, a little bit of confidentiality, integrity, and availability on that whole process. But that's really the core of what you want to remember, is that defense in depth, it's a thing we need to have, and there are very specific rules about how it works, and you should be able to know and discuss those rules. So that's it for this lecture, and I will see you in the next lecture. 8. Network security groups. The network security groups are really kind of this interesting critter. You can use Azure and network security groups to filter network traffic to and from Azure resources and in an Azure virtual network. A network or security group contains rules that allow or deny inbound traffic or outbound traffic from several types of Azure resources. So again, for each rule, you can specify source, destination, port, and protocol. So this is really kind of important on how this works. Your network engineer is going to be down here doing this a lot. This really is a network engineering job or a network security job. So the only things you need to know about it are that they exist and that there are things that go into this. And so you should have a general understanding of a network security group and the components that go into it. So there's some really nice tables and other kind of data that will help you get to where you need to be. So you really just need to know that there's a name, a priority, a source or destination port, the protocol it rides on, the direction, whether it's inbound or outbound, and then port range. So if it's port 80 for web and port 443 for secure web, DNS 53, there's all these things. And then the action you'll take, you'll either allow that traffic or you won't allow that traffic. So there's a lot of components to it. So bear with me. So there's some caveats here, right? So that 5-tuple idea that we brought up earlier, right? Source port, destination port, and protocol. It has to meet all 5 of those conditions to be used to make it happen. So it either is or is not. You cannot create 2 security rules with the same priority and direction. So basically there's a flow record is created for existing connections. So you just really need one record. One record should do it. And these records can get to be huge. So you really need to offload this. If you have your network security group being too big, think about a filtering firewall instead, just because ease of maintenance, instead of trying to rely on a network security group. Now, sometimes communication is allowed or denied based on connection state of the record flow. So make sure that your network security group is generally stateful. So if you specify an outbound security rule for port 80, it's not necessarily to specify an inbound security rule for a response to the outbound traffic. So if I've got stuff going out on port 80 or I've got stuff coming in on port 80, I don't need to have a reciprocating rule. And it's already assumed that if I can initiate that transaction, that transaction can go both ways without having a big thing. I don't need to explicitly call that out. And then you only need to specify inbound security rules if communication is initiated externally. And that's the important part. You want to make sure that port 443 is coming from anywhere in the world, but your database ports are only coming from the web server. Right? That's really how you want to look at it. And you really need to understand how systems communicate with each other to understand that. So the big thing to remember is that your network security group is stateful. You're going to specify inbound rules, and you don't necessarily have to talk about outbound rules. So default rules, there's a lot of things that come in on this, and you can kind of check it out. These are all basically what you get out of the box. And there's a long table of exactly what these are. So inbound rules, load balancer rules, deny all inbound rules. So these are all available to you as you go through the process, and they're all either inbound or outbound. Allow VNet outbound on your virtual network, allow internet outbound, deny all outbound. These are all here. You just need to go ahead and figure out which ones you want and then start configuring them. So you basically have templates for these stateful network security groups to kind of help you get started and start thinking about it. And the cool part though is now you're in the cloud. So we have what's called augmented security rules. So augmented security rules simplify security definition for virtual networks. All right, so you can define a larger and more complex network with security policies, but with fewer rules. So it's all policy driven. All right, you can combine multiple ports and multiple explicit IP addresses. So maybe you want to make sure your web server can talk to your database server through a system load balancer on specific ports, or maybe you want to do some kind of proxying between internal and external. And these are all things that you can combine into your virtual network and then make it one simple, easily understood security rule. Instead of having hundreds of network security groups, you have one augmented security rule. And again, it helps you simplify the maintenance of your security rules, and it really does help with service tags and application security groups. It's a lot better way of managing it. If you've, I've been in the network, I've seen some network security groups, and they just look like a rat's nest of stuff. This will help you out. There are limits to the number of addresses, ranges, and ports that you can specify in a rule. Then you really want to go back and see the Azure service limits for this. But these augmented security rules really do help you manage your network better. And then there's service tags. I'm a big fan of tags because it tells me who's doing what where. So if my developer team is spinning up something, I need to know because that service tag will represent a group of IP prefixes. I may actually have my developer team on a separate VLAN or a separate VPC, virtual private cloud, just to make sure that they're completely isolated because, my developers, I love them, but sometimes they make really bad code and I don't want the development environment exposed to the internet. So those are things that I'll work out. So I ask them to do service tags, or we make sure that they spin up something with specific service tags that are done automatically and programmatically for them to build their environments, and then just let them go do their thing and no one gets into any trouble. The application service groups are also enable you to configure network security as a natural extension of the application structure. You're going to have something that's web or database driven, or you're going to have some kind of visualization around it, or music or movies or whatever. You can basically group everything together. And those are nice because you can reuse your security policies at scale without having to worry about any kind of manual maintenance of it, just by breaking things into various specific groups. You may want to have the same policy across dev, test, and production for delivering movies. And this is where you can actually go do this as an application service group to test all these other things out. And then there's platform concerns, right? So you do have the virtual IP of the host node, basic infrastructure services like DHCP, DNS, health monitoring. So there's a couple of IP addresses, and I actually think you should know these, right? 168 and 169. These addresses belong to Microsoft and are the only virtualized IP addresses used in all regions for this purpose. And they will really help you work out what those services look like. And you really do want to know those two addresses. You don't want to all of a sudden say, oh, I want to be this guy. There's some metadata you can attach to too. That will look really, really cool. So effective security roles and effective routes will not include these platform roles. So you do need to make sure that you've build these things, and you can either do this via PowerShell or through the Azure portal. And again, your security group roles is your platform, DNS, LKM, IMDS, and services along the way. So just make sure that you've got some really good effective security roles around how you latch onto services. You also need to make sure that any kind of key management service for licensing for Windows is also open. The default request is made through 1688, and you do just need to have a default route out to the world. So just got to make sure that that's outbound. The platform will be disabled, but you need to make sure you leave your licensing service open because you don't want to lose licensing in the middle of doing something really super cool. Then your virtual machines, load balance pools, source port and address range, and that's all from the originating computer, not the load balancer. So remember, if you put the load balancer in front of it, you do have a separate VLAN for all your compute. The destination port and address range and your VNet and your gateway to the internet are all part of that package for your virtual machine in that load balanced pool. So you do have service instances of several Azure services such as HD Insight, application service environments, virtual machine scale sets, and all these things that are deployed in virtual network subnets. Make sure that you're familiarizing yourself with port requirements for each service before applying the network security group. You don't want to break something and then not be able to get into your stuff. So if you deny ports required by the service, that service will not function properly, and you really are going to have to go back and then figure it out. And that's why the augmented rules are a little bit easier. You can test those a little bit easier. Email is always a problem because of the way email has been used now for spam. So sending outbound email, Microsoft recommends that you use authenticated SMTP, right? So don't just use some virtual relay somewhere. Go ahead and authenticate and do SMTP relay services to specialize in sender reputation and to minimize the third-party providers will reject it. If you take a look at your rejection rates, make sure that if you're going to send customers email, which you might, because that's something you may want to do, just make sure that you're using really good, reliable email SMTP relay services along the way. So in summary, though, just make sure that all your many services require that specific ports remain open to operate effectively. Remember that you're going to do resource pooling and application pooling along the way. Make sure that your licensing, email, and other internal services can be easily blocked by network security groups or specifically authorized by those network security groups. You'll need to know that these exist and what they are for the network level in this test, but you really won't need to go much past that. You just need to know that network security groups and all that are part of the process. And that's it. That's it for this lecture. I will see you in the next lecture. Thank you. And we're going to talk about the Azure Firewall. So the Azure Firewall is really this cloud-native intelligent network firewall security service. And it works like any other firewall. Fully stateful firewall service, built-in, high availability, cloud scalability, the whole 9 yards. The thing is you need to really know about this is that it's absolutely perfect for Azure. It was written for Azure. It is cloud native and it is fully stateful. All right, so it provides all the traffic inspection that you would ever want to have that goes along with that whole part and parcel of the process. So there's actually 2 different service levels, and this is what you do want to know, is that you do want to know Firewall Standard and Firewall Premium. So Azure Firewall Standard provides layer 3 through layer 7 filtering and threat intelligence feeds directly to the Microsoft Cybersecurity Center. So that's going to be your Cloud Defender. And then from there, you can actually do some intelligence-based filtering, alert and deny traffic. You can probably even set up real-time alerting to protect you against new and emerging attacks. So pretty standard, it's what you get. Now, the Firewall Premium, though, advanced capabilities includes signature-based intrusion detection and prevention. So if you know you've got a specific signature you're vulnerable to, they will poke that in, and you can actually go ahead and take a look at it to detect those kind of attacks quicker by looking for specific patterns. Right? Those patterns can include byte sequences in network traffic or known malicious instruction sequences used by malware. And again, there's a lot to this. We've been collecting signatures for 30 years, so we know what a lot of these look like. And they're saying there's 58,000 signatures in 50 different categories now that are just things that will take over your network if you let them have a chance. So these exploit categories include malware, phishing, coin mining, Trojan attacks. There's a whole bunch of other things that premium service will help you get over and learn how to manage better. And that's what you really do want to know for the test is standard and premium. Premium includes a lot of intrusion detection and prevention, where the standard just kind of takes a look at things and intelligence-based filtering. So the Azure Firewall can be figured during deployment to span multiple availability zones. Right, so you can only need one firewall, and you can have it across multiple availability zones, and that will increase your uptime to 99.99%. So remember, your SLA here is going to be 99.99 if you are in 2 or more availability zones when you go through this. You can also associate the Azure Firewall to just one availability zone, but your service standard will fall to 99.95 as part of your SLA. So know that there's a difference. If you are in a multi-zone, you'll get 99.99. If you are a single point, you will get 99.95 as a service level agreement. So there's no additional cost for the firewall deployed in an availability zone, right? But there are additional costs for inbound, outbound data transfers associated with availability zones. So as you're round robining and you're getting things together for how you want to architect this out, make sure you've checked your bandwidth pricing details for interzone traffic. Right? As your firewall availability zones are available in regions that support availability zones, there's a few that don't. And then the Azure Firewall can scale out just as much as you need, and it can accommodate changing traffic flows. You don't need to budget for your peak traffic. It will just automatically be there as part of that cloud native solution. So for your summary, just make sure you understand that Firewall Standard and Firewall Premium for this process, and that it's basically how you are going to filter traffic and make sure the traffic that's coming into your network is the traffic that you want to have. And that's it for this section. This is a pretty short section. The firewall was pretty straightforward. Again, stateful, standard, and premium. That's really about it. And I will see you in the next lecture. A little bit about denial of service protection in section 410 of this exam. So part of what makes this kind of fun is that in security, you have specific kinds of attacks that are going to happen all the time. And denial of service is one of those. It's just one of the easiest, most disorganized way of trying to take someone out. And it really is just an attempt to exhaust the application's resources, whether that's web, whether that's bandwidth, whether that's connections to databases. Anything is a legitimate target as long as there's a resource limit and I can overrun it, I am going to try to do that. They can be targeted at any endpoint that is publicly reachable through the internet. So your system load balancers, your firewalls, all those things are also targetable. So just remember that as you go through this DDoS protection, that if it's on the internet and it has a service limit, you can attack it. There's essentially 2 levels in Azure's denial of service protection, and one of those is basic and the other one is standard. So basic is always on. It's always there. It requires no user configuration or application changes. It's just something that you get with your Azure service. And it helps protect all the Azure services, including platform services like DNS And it's essentially how Azure as a Microsoft platform tries to keep itself safe. Now you may have something more specific that you want to make sure is covered by this, and so you can go and buy DDoS protection standard. And that with your application best practices to make sure there's no single points of failure, make sure that you can scale appropriately, and some enhanced DDoS mitigation features. Standard may actually be what you need to have, especially if you've got something mission critical or human life critical or something else. You don't have to change anything. You just have to turn this service on, and it has several advantages over the basic service, including better logging, better alerting, and a little bit of telemetry. So you can kind of see how that service is working and what the DDoS attack is actually looking like. So there's some neat features to this entire denial of service platform that they've got, and then it's natively integrated into Azure, and that's inside of Azure at the data center and at the physical layers and everything to the virtualization layers. If it's owned by Microsoft, it's baked in. And this is something that you do want to remember, is that it's a native platform, right? DDoS protection standard understands your resources and resource configurations and will just do what it needs to do to make sure that nothing gets overrun. It's a turnkey protection. It's there. It's on all the time. Protection standard, as soon as it's enabled, there's no intervention or user definition required. It's all based on what's going on at the Azure level, right? Unless you've got something specific that you need to cover. Always on traffic monitoring. Your application traffic patterns are monitored 24/7. Right? They're just looking for indicators. DDoS protection standard instantly and automatically mitigates the attack once it is detected. You have a few other hoops you need to jump through for DDoS basic. And again, it depends on what you need to have. And then again, there's adaptive tuning. Intelligent traffic profiling will learn your application's traffic over time, and that's kind of a holy grail of information security, understanding what's normal and what's not normal. And then selects and updates the profile that is most suitable for your traffic service, and then adjusts as traffic changes over time. So there's some really interesting features on this one. As you kind of go through this, is that the multi-layered protection, again, at web application firewall through layer 3 and layer 4, and then the application layer 7 offered by the web application gateway, the WAF, web application firewall. So you've got a lot of neat things that you can actually tie into this, and you can buy other third-party things through the Azure Marketplace if you need it. Extensive mitigation scale, there's 60 known attack types that will be mitigated with global capacity. And then attack and analytics. You can get detailed reports in 5-minute increments during the attack, including a complete summary after the attack ends. That's great for reporting out. It just happens. You don't have to worry about it. You don't have to go and forensically analyze anything. Stream mitigation flow logs to Microsoft Sentinel or an offline security information and event system that you may have for near real-time monitoring during an attack. Now, one of the things that you really do kind of want to make sure of, though, especially if you've got a spiky company where you do have specific days for shopping like Cyber Monday or Black Friday or the day of Christmas or the day after Thanksgiving or those kinds of things where you know you're going to have a lot of traffic coming into your website, or you're a gaming company, you go to PAX, you're handing out free tokens to download the game. All that can look like a denial of service attack from Automation's viewpoint. So be really aware that if you have a special event happen, that you are on top of your denial of service protection, especially if you have standard, so that you can go in and actually try to start mitigating it, because it may look like an attack, but it's really not. So there's some things you do want to really be aware of when it comes to that, especially if you get super popular, going to PAX. Having 100,000 people download your game can be a really nerve-wracking kind of thing. But then, of course, this is PAX. PAX is awesome. So again, just some features that you do want to know about. The attack metrics are summarized, and they'll be accessible through your monitor. Attack alerting, and this can be through web, that can be through email, it can be through text. Those alerts will integrate into your operational software like monitor logs, Splunk, storage, email, and again, the Azure portal, where everything will be through the Azure portal. Then there's some DDoS rapid response, and you can actually engage the DDR team for help with the attack, investigation, and an analyst if you need to. All right, and again, these may be the people you need to contact if there's not a big deal about what you're doing because you're at PAX or it's the day after Christmas. Cost guarantees, you're going to receive data transfer and application scale out service credits for resource costs as a result of documented DDoS attacks. So you don't have to pay for it. If you all of a sudden get hit with a 400 gigabit denial of service attack, you don't have to pay for the scale out because your systems will automatically try to scale to that, and you won't have to pay for all the data transfer. So in summary, just for this test, know that you have two levels, basic, which is on by default, and standard, which has some value-added services. And they cover a broad range of denial of service style attacks. And there's a lot of support to having that along the way. But it is a neat system to have. It's great that it's just always on and plugged in at the basic level. So odds are highly likely, if you're especially a small company, you won't need anything bigger than that. But standard's got some big advantages if you're a larger company. And that's it for this lecture, and I will see you in the next section.